Good morning. Happy off-campus learning day. This is AP Calculus AB. And now that you're done shoveling the snow, those of you who served your families in that way, start our calculus lesson. We're going to use the same handout that we were working on in class on Friday with the reverse engineering task. And we're going to just review a little bit of what we did there, and then your homework will be to do a few problems from the reverse engineering sheet. That'll be paper submission due on Tuesday. So as you recall, on Friday we were looking at the definite integral from 1 to 5 of square root x plus sine x dx. And we started that process, first of all, by approximating it with a right-hand Riemann sum with 7 rectangles. And then we went back and said n rectangles. And what we said out loud and in unison was that the definite integral is a limit of a Riemann sum. So if you want to write this on a separate sheet of paper, it's up to you. This is basically something that we already did in class, but I just want to bring this full circle. A definite integral is a limit of a Riemann sum. So it's a limit as n approaches infinity of all of the rectangle widths, and the widths are b minus a over n. So b minus a is 4, 5 minus 1 is 4 over n. Those are the widths, so I factor those out. And the first length, if I were to draw just a little bit of a generic graph here, starting at 1, so right-hand Riemann sum, the first rectangle, the second rectangle, and the nth rectangle are the only ones I need to draw. So the first rectangle is over here at 1 plus 4 over n. The input, or the golf ball, there is 1 plus 4 over n. So the first height is going to be the square root of 1 plus 4 over n plus the sine of 1 plus 4 over n. And then the second golf ball is going to be 1 plus 2 times 4 over n. So I'm going to write square root of 1 plus 2 times 4 over n plus the sine of 1 plus 2 times 4 over n plus dot, dot, dot. And then the nth input will be 1 plus, not 1, not 2. The first pair had a 1 out front, the second pair had a 2. This will be n times 4n over n under the square root. Let me put a plus sign out front, dot, 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 plus sign. And then that's plus the sine of 1 plus n times 4n over n. And so what we're doing in this lesson is learning how to reverse engineer these Riemann sums. And so this limit of a Riemann sum will be the question, and then the answer will be the definite integral. The definite integral from 1 to 5 of square root x plus sine x dx. Now, in order to reverse engineer this, I need to know the function, and the best way to see the function is to first of all circle the golf balls. So this first pair of inputs we'll call C1. The second pair of inputs, it's like the second golf ball, we'll call it C2. And this last pair of inputs, and I notice that parentheses does not need to be there. I'm going to get rid of that parentheses. So the last pair of golf balls is this pair labeled C sub n. So you need 3 things to reverse engineer the limit of a Riemann sum. The first is a function, and in this case we can tell that the function has inputs of whatever the golf balls are, and look around the inputs to find out what the function is. It looks like we're taking the square root of an input plus the sine of an input. So that is the function. To find a, you take the limit as n approaches infinity of c1, which in this case is 1. So the integral from a to b. A is 1. To find the value of b, take the limit as n approaches infinity of golf ball c sub n. And the limit as n approaches infinity here, the n's cancel, is 1 plus 4 or 5. Now, the answer, therefore, suppose we didn't know the definite integral. Based on this work, we can tell that the answer is the definite integral from 1 to 5 of square root x plus sine x dx. Now, there's one detail that you have to verify on the more difficult problems, and that is, what's the difference between the golf balls? Like, take C2 minus C1. So 1 plus 8 over n minus 1 plus 4 over n leaves you a difference of 4 over n. And that difference matches with the widths of all the rectangles out front, so that tells you you don't have to doctor and counterbalance. Let's try another example. And actually, let's fill in the notes here on the bottom. So, yeah, does the first caret match delta x is what it says. We circled the golf balls, we labeled them, we drew the difference caret, and we subtracted C2 minus C1. Did that match? Yes, it did. If yes, go to step 6. If not, doctor and counterbalance. So step 6 is basically we got, we looked at the pattern using the C sub i's. And down here where it says number 7, a equals, that's always going to be the limit as n approaches infinity of C sub 1. And for letter B, number 8, letter B, that's always the limit as n approaches infinity of C sub n. Okay, so let's do an example on the next page. And that says try it with a different circling. So the alternate circling, which we're going to check on the calculator to see if both of these agree. So have your calculator out and ready to go. But on this next page, as we look at the alternate circling, we're going to rewrite this definite integral as 4 over n times, just like before, the square root of 1 plus 4 over n plus the sine of 1 plus 4 over n, plus the second pair of golf balls, that's going to, well, the second pair of inputs is going to be 1 plus 2 times 4 over n, plus the sine of 1 plus 2 times 4 over n, plus dot, dot, dot. Then the last one is the square root of 1 plus n times 4 over n plus the sine of 1 plus n times 4 over n. What do we mean by an alternate circling? Well, some students might look at a problem like this and say that the first golf ball is whatever comes after the 1 plus. So 1 plus golf ball. 1 plus, so this is golf balls C1, that pair. Then 1 plus golf ball. They might say, well, this is C sub 2, and then 1 plus golf ball C sub n. This is an alternate circling. If a student thought that the pattern they see is that in every term, and the terms come with 2 terms, or 2 subterms per term. So here's the first term, second term. Some students might look at this and say that the terms are following the pattern of f of x equals the square root of 1 plus a golf ball plus the sine of 1 plus a golf ball. That's circling of 1 plus golf ball. 1 plus golf ball is consistent even in the last term, in the nth pair of terms, 1 plus golf ball. So this is an alternate way of doing it, in which case A would be the limit as n approaches infinity of 4 over n, which is 0. And B would be the limit of the last golf ball, the limit as n approaches infinity of 4n over n, which is 4. Therefore, an alternate way to write this problem, if someone did not have the limit of a Riemann, or if they had the limit of a Riemann sum, which, look at this, I forgot to write limit out front, limit as n approaches infinity. If all they had was a limit of the Riemann sum and they had to come up with a definite integral, using the first circling, they would have come up with this one, but using this alternate circling, they would have come up with the integral from 0 to 4 of the square root of 1 plus x plus the sine of 1 plus x dx. And we're going to show on the calculator that both the integral from 1 to 5 of radical x plus sine x dx and this one give the same answer. So on the calculator, let's type both of these in. First of all, on Math 9, let's type in the definite integral of square root x plus sine x with respect to x from 1 to 5. Notice that gives us 7.0435, but the alternate circling, Math 9, is the square root of x plus 1 plus the sine of x plus 1 with respect to x from 0 to 4. Hopefully that gives the exact same answer. It does. So this example, this alternate circling example, just shows that as long as your circling is consistent in terms of what the pattern is in the first term, the second term, and the nth term, then it's a legitimate circling. Some students will circle things differently. So on the next page, let's take a look at problem 1. It says rewrite the sum as a definite integral. Note whether it's a right midpoint or left-hand Riemann sum. So there's more than one way to circle this. And I mean, it seems to me that one way to circle it is that it's golf ball squared plus 5. Golf ball squared plus 5, and then golf ball squared plus 5. So this would be C1, C2, and C sub n. Now, we might have to doctor and counterbalance this. Let's find out. Let's draw this difference caret. And when you take golf ball C2 minus golf ball C1, you get 7 over n, which does match with all of these widths. So there's no doctoring, no counterbalancing required. On this particular circling, it looks like we have input squared plus 5 every time. So I believe that f of x, this is kind of cramped here, so I'm going to write it, the f of x over here. F of x equals input squared plus 5. The limit as n approaches infinity of C1 is 3, and the limit as n approaches infinity of C sub n is 10. So one of the, and yes. And by the way, this does look like a right-hand Riemann sum. So, using the orange circling, the definite integral for problem 1 is the definite integral from 3 to 10 of x squared plus 5 dx. That's using the orange circling. Now, we're going to look at some blue circling. The orange circling is not the only way to do it. You could, let me see here. Yeah, if you're going to do an alternate circling, it would be 3 plus a golf ball, 3 plus a golf ball. So the fact that this last one is not in the form 3 plus a golf ball just shows that this circling method is harder. You would have to rewrite this as 3 plus 7n over n, quantity squared plus 5. So now the nth golf ball would be 7n over n, C sub n. So if this were the circling, then the function f of x would be quantity 3 plus golf ball squared plus 5. And the final answer would be the definite integral from 0, because the limit as n approaches infinity of 7 over n is 0. And the upper limit of integration would be 7. So it'd be the definite integral from 0 to 7 of 3 plus x quantity squared plus 5 dx. Now, I'll leave it to you to type the orange one into your calculator and the blue one into your calculator to verify that both of them give you the same answer. Okay, so one of the things I'd like you to do for your homework is to do problem 2. This will be paper submission right here on this sheet. You'll just be turning in this whole packet because I want to verify that you took notes on this packet from the video and that you did the homework, fill these in. So the first one I want you to do on your own is number 2. In fact, you can just pause the video and do it now if you want. Okay, so now number 3 is the next one that we're going to do as a class for notes. And for this one, I want to make sure that you know how to do circling where you have to rewrite this last one. So let's try, even though this is not the only way to circle this, I could have made the first circle 8 plus 2 over n. But let's just do the circles in red. Suppose we decide to make the pattern sine of square root of 8 plus golf ball. 8 plus golf ball. So C1, C2, 8 plus the golf ball, C3. And since this one doesn't have 8 plus, we have to rewrite it so that our circling pattern is consistent. So I'm going to rewrite this as the sine of the square root of 8 plus, let's see, 8 plus what is 14? Be 6. Why can't you just write 6? Well, the way that these things turn out, when you start with a set of rectangles, as we saw earlier, is the n form. I mean, you see a 6 over n times n. So it's like 2 over n times 1, 2 over n times 2, 2 over n times 3. So this ended up being 6n over n. Now, our last circle, therefore, our nth circle, is in red, 6n over n. Now, let's check here, though. The difference, 4 over n to 2 over n, is 2 over n. Now, we don't have a 2 over n. That's a mismatch. The distance between the golf balls is not 2 over n. It's 1 over n. So we have to doctor this 1 over n up. I'm going to doctor it in green. I'm going to multiply this 1 over n by 2 over n so that it matches the differences between the golf balls. But that means that I have to counterbalance with a 1/2 out front. If I doctor with a 2, I have to counterbalance with a 1/2. So it looks as though the function we're going to use for this one, using this circling, which is not the only circling possible, but it looks like it's f of x equals the sine of the square root of 8 plus an input. So the lower limit of integration will be the limit of 2 over n, which is 0. The limit of 6n over n is 6. So the final answer is 1/2, which came from the counterbalancing, 1/2 times the definite integral from this limit at infinity is 0. The last golf ball's limit at infinity, this is golf ball C sub n, is 6. So it's 1/2 times the integral from 0 to 6 of the sine of the square root of 8 plus x dx. I think it would be a good idea for you to try an alternate circling and type it into your calculator and see if it matches this one. In the alternate circling, you'd probably want 8 plus 2 over n to be C1. Let's go to the next page. All right, so number 4, I can tell you right now, is an example which I want you to do as part of your off-campus learning day homework, where doctoring will be required. You're going to have to doctor and counterbalance in number 4. So let's go to number 5 and work it together. Problem 5. Okay, tell you what, for this one, go ahead and I'll work it out, but go ahead and press pause, try it on your own, and then when you press play, you'll see my solution of it. So go ahead and press pause. All right, we're back. So one of the circlings you could do is, I'm going to do what I think is probably, let me see here, 1 plus 14. So it looks like there's nothing wrong with making this your first circle, C1. Not the only way to do it, but second circle. And then C sub n. Now, what is the difference between C2 and C1? What is C2 minus C1? Does it match 6 over n? Let's find out. They both have a 15 in them. So the difference is really the difference between 84 over n and 42 over n. This fraction minus that fraction is 42 over n, which does not match 6 over n. So I've got to doctor up the 6 over n, and I notice that 6 times 7 is 42. So I'm going to doctor with a 7 and counterbalance it with a 1/7. So I think that one of the answers that you could write for this is 1/7 times the definite integral from 15 all the way up to, I just took the limit as n approaches infinity of the first golf ball, which is 15 plus 0. And then the limit as n approaches infinity of the last golf ball is going to be 1 plus 14 plus 56. So that's 60, 70, 71. 60, 70, 71. All right, and it looks like, oh, by the way, the function that we're using here, every term has a 4, a cosine, and a golf ball. So it's 4 cosine x. So 4 cosine x dx, which, by the way, if this were on the AP test, they might just ask you to find the value of this limit of a Riemann sum. So finding the definite integral would be just really the first step. And then next what you would do is take 4/7 times the antiderivative of cosine, which is sine x, from 15 to 71. So that would be 4/7 sine of 71 minus sine of 15. Of course, that's radians, not degrees. So if someone asks you, what's the limit of this Riemann sum? You could say, well, that is just 4/7 sine of 71 minus sine of 15, or 4/7 times the quantity, sine of 71 minus sine of 15. Okay, let's go on to the next page here. In this one, the only difference between this and what we've done previously is that the limit of the Riemann sum is in sigma form instead of in ellipsis form. So you can fix that by recognizing that this is length times width from 1 to infinity. So you could rewrite this as the limit as n approaches infinity of, and I'm going to just keep the 2 over n out front because it doesn't have an I in it, so it's the same every time. And first of all, let I equal 1, so it's 1 plus 1 over n plus. Now let I equal 2, 1 plus 2 over n plus 1 plus 3 over n plus dot 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 plus 1 plus n over n. So this is the limit of the Riemann sum, which, by the way, when you check to see whether or not doctoring and counterbalancing is required, suppose I do this circling. It's not the only circling. I could just let f of x be x, because it's blah, blah, blah. So we could just let f of x be x. But here I'm going to be having you finish this one on your own. But this is why I would recommend you let f of x equal 1 plus x. 1 plus x. That's the pattern throughout. Notice that the first difference caret C2 minus C1 is 1 over n, which does not match the 2 over n. So here, to turn a 2 over n into a 1 over n, all of these differences are 1 over n. I have to doctor with a 1/2 and counterbalance with a 2. So the last problem that I want you to do for off-campus learning day is to finish problem 6. So that concludes the lesson. We'll see you on Tuesday.